We will now continue with section 3.1, Relations and Functions. We will begin with a definition for function notation. Suppose a function is represented by an equation in two variables, say x and y, and we can solve this equation for y, the variable representing the range. We can name the function. Frequently we use the letter f and write it in function notation by solving the equation for y and replacing y with f of x. So as an example, with the function y is equal to 2x minus 3, we would first solve it for y if it wasn't already solved for y, and then we would use function notation and replace the y with an f of x. And so the function becomes f of x is equal to 2x minus 3. So our first example asks us to take each of the following equations, which represents a function, and rewrite each one using function notation, and then evaluate the function at x is equal to 3. So writing it with function notation simply means that you're going to solve for y, if that's not already done, and then you are going to replace the y with an f of x. So this function, f of x, is equal to 3 divided by x plus 2 is now solved and written using function notation. We're then asked to evaluate the function at negative 3. So we're asked to find f of negative 3. To find f of negative 3, we simply rewrite our function, and everywhere there's an x, we'll replace it with the negative 3. So the 3 divided by x becomes 3 divided by negative 3. The plus 2 stays the same. 3 divided by negative 3 is negative 1. And negative 1 plus 2 is going to be a positive 1. So what this tells us is that on the graph of this equation, if x is equal to negative 3, then the y value is equal to 1, and that is a point on the graph of that equation. For part B, we want to write 7x plus 3 is equal to 2y minus 1 using function notation. So first we want to solve for y. So the easiest way to solve for y is going to be to add 1 to both sides of the equation, which gives us 7x plus 4 is equal to 2y. And then divide both sides by 2. And remember that dividing by 2 really means dividing each of these terms by 2. So we have 7 over 2 times x plus 4 divided by 2 is 2 is equal to y. And I'm going to turn this around so that it's y is equal to 7 halves x plus 2. And then I'm going to write it with the function notation, which means that I'm going to replace the y with an f of x. So we have f of x is equal to 7 halves x plus 2. I now want to evaluate my function at negative 3, which again means rewrite your function, and where there's an x, we're going to enter in a negative 3. So we'll have 7 halves times negative 3 plus 2. So this gives us 7 times negative 3 is negative 21 over 2. Let's write this 2 as a fraction with a denominator of 2. So what over 2 is equal to 2? That would need to be 4. And adding our two fractions together, we're going to have negative 17 over 2. And so again, if we are graphing this equation, we would expect if the x is equal to negative 3, the y would equal negative 17 halves, and that is a point on the graph of the equation. Our next example is y minus 5 is equal to x squared. And so we'll begin by solving for y by adding the 5 to both sides. So y is equal to x squared plus 5. To write it in function notation, we'll replace the y with an f of x. So f of x is equal to x squared plus 5. Our next thing is to do f of negative 3. So again, we're going to plug a negative 3 in for the x's in the equation. So we have negative 3, the quantity squared, plus 5. So negative 3 times negative 3 is 9, plus 5 is going to give me 14. So again, on the graph of that equation, if the x is negative 3, the y is 14, and the point negative 3, 14 should appear on the graph of the equation. Our last part, the square root of 1 minus x minus 2y is equal to 6. And so again, we will begin by solving for y. So I am going to subtract this square root first from both sides. So that's going to give me negative 2y is equal to 6 minus the square root of 1 minus x. We're then going to divide both sides by negative 2. And again, dividing by negative 2 is essentially dividing both of these terms by negative 2. So I get y is equal to 6 over negative 2 is negative 3. The subtraction and the negative make a positive. Square root of 1 minus x divided by 2. And we'll write it in function notation by replacing the y with an f of x. And it should be noted that even though we're using an f for all of our function, it doesn't have to be an f. It could be another letter altogether and still be function notation. So in your homework, you'll see g of x and h of x. It's all the same thing. We're using a letter to represent the name of the function. All right, and our last part is to evaluate at negative 3. So we'll take our expression, and where there's an x, we will put a negative 3. And so now we have negative 3 plus the square root of 1 minus negative 3 is 4 over 2. We know the square root of 4 is 2. Two over 2 is going to be 1, so we have f of negative 3 equaling negative 3 plus 1. And so f of negative 3 is equal to negative 2. And so again, if the x value is negative 3, the y value that goes with it is negative 2, and we would expect this to be a point on the graph of our original equation. Our next example asks us if we're given the function f of x is equal to 3x squared minus 2, to evaluate, and part A says f of a, and so asking us to evaluate at a particular variable. So all this means is we take what's in parentheses, which is the a, and wherever there's an x, we're going to plug it in. So we'll have 3. When we come to this x, we're going to replace it with an a squared minus 2. And really that's all we do on that one. Just replacing the x with an a. So our next example asks us to evaluate our function at f of x plus h. So here we replace the x with an x plus h. So we have our 3, we have an x, so I'm going to keep that x plus h in parentheses. We have the squared and we have the minus 2. Now we want to be careful with the simplifying. We want to remember that x plus h squared is really x plus h times x plus h. So I'm writing it off to the side so that I can see it. And we're going to do the FOIL method over here. So first times first is x squared. Outside will be xh. Inside will be xh. And last will be h squared. We can now combine those middle terms. So we'll have the 3 times the quantity x squared plus, we now have 2xh plus h squared minus 2. We will distribute that 3, making it 3x squared plus 6xh plus 3h squared, and then minus 2. And finally, and this one is probably a little more difficult, we want to evaluate our function at f of x plus h minus f of x divided by h. So remember that your function is 3x squared minus 2. All right, so let's begin with the x plus h. So we're going to rewrite our function, and when we come to an x, we're going to replace it with x plus h. So I've got the 3. I'm going to make my replacement here, x plus h squared minus 2. And then we have minus f of x. So minus, and let's put this in a bracket so we can deal with this subtraction in just a minute. And we know that f of x is equal to 3x squared minus 2. And we're going to divide by h. Now, this part was what we worked out in the previous example. So we already know the answer to this part right here. So let's go ahead and add that in. 3x squared plus 6xh plus 3h squared minus 2 is what we had, was we copied from the previous problem. I'm now going to distribute this negative through this bracket. So minus 3x squared plus 4 over h. And then we will combine any terms that we can combine. So notice that we have a 3x squared and a negative 3x squared. Those will cancel out. So we have a 6xh, we have a 3h squared, and we have, that takes care of those two, a negative 2 and a positive 4, that's going to be a positive 2 over h. And it looks like, hold on just a second, did I make a mistake? Yes, I made a small mistake. So let me go back and fix this. Hopefully you caught that as you were working it out. When I distributed this negative, I went negative 3x squared, and then it should be positive 2. So let's fix that right there. And I apologize for that mistake. So that should be a positive 2 there, which would cause those 2's to cancel out. So we actually have 6xh plus 3h squared over h. All right, further simplifying, I can factor out an h out of the top part of that fraction. So if I take an h out of 6xh, I'm left with 6x. If I take an h out of 3h squared, I'm left with 3 and one of the h's. And I do that so that I can then cancel 1 in the top with 1 in the bottom, leaving me as a final answer 6x plus 3h.